All right, here we go. So this is number 2. So we're given a particle moves along a coordinate axis. Positive direction is to the right. So this particle is just moving along this line back and forth in some way. How? Well, according to that equation right there, we want to find its velocity at one, let's call it second. Okay, so this could be meters per second, for example. So velocity, and then meters could be our position at any time in seconds. All right, let's see. First, I'm going to write down my velocity function, which is the derivative of the position function. How about 3t squared minus 4? If I start with t cubed, derivative of that is 3t squared. And derivative of negative 4t would be negative 4. Derivative of 1 is 0, so that should be the derivative there, right? Yeah. Okay, and then we plug in a 1. All right, so v of 1 is going to be a 3 times 1 squared minus 4, which is 3 minus 1, 4, excuse me, which is negative 1. All right, next question. Is the particle moving left to right, right to left, neither? That time equals 1.
Well, if it's positive, it's going from left to right, because right is the positive direction.
Positive would be left to right, so negative must be right to left. Yeah. So at 1 second in, it's heading back toward where it started, because it has a negative velocity. It's losing distance if going to the right is positive. So it is moving right to left. All right, next we want to find the acceleration. So acceleration, remember, is the derivative of velocity, which happens to be the second derivative of position. So derivative of the equation above would be 6t, right?
Yeah.
3 times 2t, and then derivative of negative 4 is 0. That would just be 6t. Plug in 1, okay? 6 times 1 is 6. Okay, so acceleration is which direction here?
Speeding up.
We'll answer that question in a second, but just think about the positive. Acceleration is changing velocity in a positive way, is what this tells me. The acceleration is increasing the velocity.
What if the acceleration was negative, like negative 6?
Then that would be decreasing the velocity. So the question is here, is it speeding up, slowing down, or neither? Which is a different question than I just mentioned. So think about it for a minute, pick an answer, and then we'll look at the graph to verify. Okay, so how many people vote for speeding up? 1, 2, 3, 4, 5 people. How many people vote for slowing down? 1, 2. You just changed your vote?
Yeah.
Okay. How many people vote for neither? How many people abstained? I know some of you abstained here. Okay, that's okay. So it looked like we had more people on the speeding up than slowing down. So I think we had like 4 to 2 and then a bunch of abstentions. Okay, so let's look at the graph and see. So whip that out on Desmos. The original function, t cubed minus 4t, we're going to have to use x's plus 1. Okay, so I'm going to call it s of x, which equals x cubed minus 4x plus 1. Did I get that right? Yeah. Okay. And then I only care about what's going on at 1, which is this point down here. Oops, let's graph the point. 1 comma s of 1 at that point right there. Think about the tangent line at that point. I'm going to graph it just for fun. It would be y minus s of 1 equals, what did we find the velocity to be there? Negative 1? Negative 1 times x minus 1. There's my tangent line. Negative slope, right? The particle, now here, in this view, we have to think positive is up and negative is down. Particle's moving down. Okay. But acceleration wants it to go up. The acceleration is resisting the velocity. What's the next, if we move just a tiny bit to the right with that point, is the next slope going to be shallower or steeper? Shallower. So it's slowing down. It's slowing down because gravity, or not gravity, acceleration is opposing the current velocity. The acceleration there is opposing the current velocity.
I still don't understand how you got part B of that. I understand that part.
Okay, let's go back here. Which part?
The right to left.
Yeah, so up above, it says positive is to the right.
Oh.
So if it were moving to the right, that means that's a positive distance and a positive velocity. We just discovered there's a negative velocity, which means it must be decreasing the position. So it's going to be heading back towards where it started.
I see.
Because we're decreasing its position. Yeah. Okay.
So if you're going up, then the force of gravity would be slowing you down.
Yeah, so when I threw that ball earlier, it started moving relatively fast, but then it was slowing down because gravity's taking away from that upward velocity. Because gravity is changing velocity in a negative direction. Here, this is like the opposite of gravity. Right? We're changing it the other way.
So
Like maybe a magnetic attraction.
to solve for D, we'd have to graph it to know.
There's two ways to think about it. One way is to graph it to see that, oh, the slopes are getting shallower. So that means it's slowing down. The other way to think about it here is that the acceleration is opposite
Oh,
the velocity.
so if there's negative, it would.
So if we found a velocity, if we found that that the acceleration was negative there, then the speed would have been increasing because the velocity is saying, yeah, keep going in this direction.
And then if it was zero, it would be neither.
If zero would be neither.
Yeah.
Well, how do we find out on the gravity? Or we can plug like in another point?
So if the acceleration is opposing the velocity, it's going to be slowing down. If the acceleration is in the same sign, positive or negative, as the velocity, it's speeding up. And to double check that, you can always look at the graph and see are the slopes getting steeper or shallower. Yeah, this is a mind-bending one, right? I had to think about it a couple different ways before I assured myself, okay, yeah, that's what's going on here. It's hard. So I highly recommend doing this problem again, trying to decide and looking at the graph to double check. And if you want to really challenge yourself for fun, pick a different X value and then come ask me about it later and get my opinion on it. Or send me a message.
Well, that's you.
Bless you.